Hello everyone, welcome to R8 School. In today's lesson, we will be learning how to apply Riemann sums, and this means estimating the area under the graph. So what does it mean to estimate the area under a graph? It means that you will be using rectangles to find the area, and this means that you will be using Riemann sums. So this is the method. Step 1. Identify the partition which is N. Step 2. Identify the interval AB. Step 3. Calculate the width of the rectangle, which is equals to change in x, which is change in x equals to b minus a over n, where b is your upper bound and a is your lower bound and n your partition. Step 4. Decide to use right endpoints or left endpoints. And after you decided which one you want to use, you must calculate your chosen endpoints. If you are using right endpoints, it is equals to change in x multiplied by I, and left endpoints is equals to change in x multiplied by I minus 1. Step 5. List your endpoints. Step 6. Apply your summation formula. So let's look at an example. A. Estimate the area under the graph of f of x equals to cos x from x is equals to 0 to x is equals to pi over 2 using 4 approximating rectangles. B. Is your estimate an underestimate or an overestimate? So the solution for this is as follows. Using the steps, the first step would be to find the partition which is N, and from the question we are told that we are required to use 4 approximating rectangles, and therefore, since there are 4 approximations, the partition is 4. There are 4 partitions, therefore n is equals to 4. Step 2. Identify the interval AB. So in the question we are told that we need to estimate the area under the graph of f of x is equals to cos of x from x is equals to 0 to x is equals to pi over 2. And that is our interval, where x is equals to 0 is the lower bound, which is a, and x is equals to pi over 2, which is the upper bound, b. Step 3. Identify the width of the rectangle. And the width of the rectangle is change in x. Now, this is the formula to calculate the width or change in x, and that is equals to b minus a over n, which change in x is your width, b is your upper bound, a is your lower bound, and n is your number of partitions. So let's do that. Change in x in this case is equals to pi over 2 minus 0 divided by 4, and that is equals to pi over 2 multiplied by a quarter, and therefore change in x is equals to pi over 8. Right, now for step 4. Decide to use right endpoints or left endpoints and then calculate your chosen endpoints. So I'm going to go with right endpoints. If you use right endpoints, you calculate it by using the following formula. Change in x multiplied by I. If you want to calculate left endpoints, it is equals to change in x multiplied by I minus 1. So if I calculate the first right endpoint, it will be equals to change in x, which we just calculated, which is pi over 8, multiplied by 1 since I'm calculating the first endpoint. Therefore, I in this case is 1 and that is equals to, so pi over 8 multiplied by 1 is pi over 8. I2 is equals to pi over 8 multiplied by 2, which is equals to 2 pi over 8. And my third right endpoint is equals to pi over 8 multiplied by 3, which is equals to 3 pi over 8. And my fourth right endpoint is equals to pi over 8 multiplied by 4, which is equals to 4 pi over 8. So now for step 5, we need to list the right endpoints and the left endpoints. This helps with drawing the graph, and I will be drawing the graph a little bit later to show you the graphical estimate of the area under the curve. So the first set of endpoints, left endpoints and right endpoints, is 0 and pi over 8. The second set is pi over 8 and 2 pi over 8. And the third left endpoint and third right endpoint is 2 pi over 8 and 3 pi over 8. And the fourth left endpoint and the fourth right endpoint is 3 pi over 8 and 4 pi over 8. Now, did you notice something from the endpoints that I highlighted? That is the interval for the function f of x is equals to cos x, right over here. And this is the interval that we are working with to estimate the area. Now for step 6, we will apply a summation formula. So the formula to calculate the right endpoints, well, rather the formula to calculate the area under the curve using right endpoints is as follows, which is written in red. So if I substitute, earlier we have calculated the width of the rectangle, which is change in x. So therefore I substituted over here pi over 8, and our number of partitions, we're using four approximating rectangles. So n is equals to 4, and I is equals to 1, and I'm going to be substituting my input values right now. As you can see, I'm bringing this to the front just to make it easier to multiply with. Well, it doesn't matter if you multiply it over here at the back, but it's multiplied by the sum of all of this. So these are just additional steps for explanation purposes. And if I then substitute each of these input values into the function, which is f of x, and our f of x is cos x, right? Let's do that. So if I then substitute in, my area is equals to 0.790766, and it carries on. And yes, you need to show the step. This is quite a necessary step. This is what you would write down in your answer. So if I want to, that is rounded off to 0.7908, and that's the area under the graph, right? That is the estimated area under the graph of f of x is equals to cos x. So now for B, is your estimate an underestimate or an overestimate? Let us answer this question using a graph. So let's draw that. So I've got my axis over here, and don't forget to label it x-axis and y-axis. There's my 0 and there's 1. Now if you recall from a standard cos graph, the highest y value that you can get is 1, and therefore we will only be working between the range of 0 and 1 for this graph. And since our interval is only between 0 and pi over 2, this is what the cos graph will look between this interval. So now what I'm doing is listing my partitions: pi over 8, 2 pi over 8, 3 pi over 8, and 4 pi over 8, which is equals to pi over 2. And now we're going to draw the rectangles. Important to remember, since we are using right endpoints in this case, you could use left endpoints, but you could in this case I chose to use right endpoints. So when you use right endpoints, the right ends of each rectangle is what touches the graph. So in this case, since we are using right endpoints, the right basically the right endpoint of the rectangle is what touches the graph, and that's very important to note when drawing the graphs with Riemann sums. If I draw my second rectangle, that's what it would look like. The third one and the fourth one, well, since the right endpoint is what touches the graph, it will touch the graph where y is equals to 0. So therefore, it is basically on the x-axis. So there isn't any rectangle in this case, right? But what do you notice? So there we go. Important that it touches the right end touches the graph. And what else do you notice? The question asks, is our estimate an underestimate or an overestimate? If it was an overestimate, our rectangles will be covering an area larger than the area of the cos graph in this case. But none of our rectangles is actually covering a larger area than the area of this section of the cos graph. Instead, it is an underestimate because do you see all the empty space? So therefore, our estimate is an underestimate. Thank you so much for watching. Until next time.